is 10 times more acidic than a pH of 7. And another
One
scale
more
that
time.
you're familiar with would be the Richter scale for earthquakes.
Hmm.
So a 3, you might feel an earthquake with a Richter scale of 3, but 4 you're going to feel because it's 10 times more powerful than 3. And 5 you're definitely going to feel because it's 100 times more powerful than 3. And a 6, stuff starts falling down like buildings and bridges because then it's 1,000 times more powerful than the 3. What keeps the acid in your stomach from burning a hole in the lining? That's a really good question. And the answer to that is mucus. So the inside lining of your stomach is covered with this very thick waxy stuff. It's a lot like the wax that you would have with if you were going to apply it to a snowboard or skis or something like that. It's seriously thick, and the waxiness is the substance is actually a prostaglandin, which is a type of fat molecule. And the interesting thing about prostaglandins is they're a part of the inflammation process. So if you take something to stop inflammation, you actually reduce the amount of thickness to that lining in your stomach. So the reason that an aspirin can cause stomach problems is the aspirin itself stops inflammation. Well, the process of creating the prostaglandin cover on the inside of your stomach is basically an inflammation process. So you stop making that, and then you can get upset stomach because now the acid actually has access to your stomach instead of just being. If you put acid on wax, it's like putting it on plastic. It just sits up top. It does not interact with it. One's polar and one's nonpolar. So if I coat my stomach with something that's nonpolar, then the acid won't attack it because it doesn't want anything to do with it. It's the reason you can put vinegar inside of a plastic container and the plastic container doesn't dissolve.
Mm. I, yeah, I remember when I worked at the clinic, they said, don't do too much aspirin because you're gonna kill your stomach. What they're meaning is the lining of your stomach.
Yeah, you reduce the amount of protective coating on it.
I guess that's why a lot of the patients that were on an aspirin, I guess more so for like maintenance blood thinners, but they also were taking like an omeprazole with it too.
Which reduces proton production in the stomach.
Hmm. Makes sense.
What's the chemical makeup of the prostaglandin? It's big. Let me just a sec here. Exit full screen. I just want to do that. Do Q. No, not videos. Pics. We'll go. Huh. Wait, is it Prosta? Proste? How about just Prost? How about, I guess I don't have a picture in there. Weird. Okay. Open in a new tab. That's the wrong color. There we go. All right, so meeting, share, screen two. That's what it looks like. That is a prostaglandin. So it's going to vary because there's lots of different prostaglandins.
I
What
don't see anything.
happens? You don't see anything?
Nope.
Oh, sorry. Let me try that again. How about now?
Here we go.
Okay. So there are lots of different prostaglandins, and they vary based off of what the side chains are, or the functional groups. And the functional groups are those OHs and the O's that are doubly bonded to a carbon. Anytime there's a corner or an end, if it just ends, like it just ends right here, that's a carbon. This is just how chemists draw it because otherwise it takes a really long time. So this is a prostaglandin. So your stomach would be lined with something like this, very similar to this molecule. And then this doesn't get produced if you take something like ibuprofen or aspirin or naproxen sodium or something more powerful like anything that deals with eczema, which is an inflammation issue, or rheumatoid arthritis, like Celebrex, stuff like that. Those substances have to be taken with food and have to be taken like you. There's a specific time that you need to be eating and taking that because it causes problems otherwise.
Mhm. What's that like dark space right by where that arrow that's not moving is?
This?
Yeah, is that just a type of bond?
No, it's a single bond between this carbon and this carbon, but it's coming at you because this is a three-dimensional structure. So that's how a chemist tells you what the structure is. These dash lines mean those are bonds going away. So this chain right here, so this pentagon here, all of those carbon atoms are basically in a flat disc-shaped pentagon. And this chain is connected to that flat disc, but it's behind it. And this chain is in front of it. It's closer to you. And this one, this OH group down here is going away from you at an angle of 109.5.
So we're seeing it at 2D, but really it's kind of 3D.
No, everything is 3D. There aren't 2Ds. Unless you get down to incredibly small molecules, they could be 2D. But all carbon molecules, unless we're talking about, say, carbon monoxide or carbon dioxide, something really small, they're all going to be three-dimensional. All of these carbons actually have two hydrogens attached to them if there's nothing shown. So that carbon right there, there's a hydrogen coming at you, and then there's also a hydrogen going away from you. But it's not shown because anybody who's looking at this molecule understands that they have to be there.
Okay, I see.
Definitely not part of this class.
Yeah, I was gonna say I'm like, oh, kind of looks like alienness here, but I know. So Rob, remember how you were telling me about the agricultural program at OSU, and there's
Yeah,
like the direct partnership program. So I am gonna do that.
awesome. Sweet. Did you talk to Ann Harris?
I did, yes. She kind of pointed me in the right direction, and then I'm in contact with Rick, the advisor there, and then once I actually apply, they're going to get me in contact with the advisor for the agriculture program there.
Awesome. Well,
Yeah.
good
Okay.
job. You should enjoy that.
I appreciate you mentioning it. I didn't know about it, and I didn't know they had an online program because that's like the biggest thing is not being able to
Sure. Oregon
go there
State's
because
Oregon State's by far the biggest university in the state, like hitting online.
hmm I heard their online program is like top 5 in the United States or something like that for you
You
know
you're going to use a
visualization.
completely different program called Blackboard, but whatever.
Say again?
They use something called Blackboard instead of Moodle.
I've
Um,
heard of Blackboard, but I haven't been on Black before.
um, we, yeah, yeah, yeah.
I like
So
Moodle. I mean, how much different is Blackboard than Moodle?
you're not going to. It's going to look a little bit different, but not that much.
Okay, same concept of things.
Everything else, it's going to have all the same things that you have in Moodle. You're going to have there.
Okay, cool.
Since all elements are trying to reach 8 electrons, how does that work when more orbits of electrons are there? More orbits of electrons are there. I'm not sure what that means.
There's a lot of shit going on right now.
Yeah, Bethany, I'm sorry, I don't understand what more orbits of electrons are there.
Does she mean the rings,
I'm not
like
sure.
the outer layers?
Are you talking about this prostaglandin molecule? There's still only the carbon atom Let me draw something. So the carbon comes with 4 electrons, and it wants to see 8 electrons. And so in that ring structure, that's my best pentagon, that this spot right here is a carbon. And this spot right here is a carbon. And this spot right here is another carbon. And this one's another carbon, and that one's another carbon. So I have this structure, and they are all connected to each other with single bonds. But carbon needs to see 4 bonds, and so it's not seeing 4 bonds. So then, with each of these positions, I would put 2 hydrogens on each carbon. And now you can see why chemists want to draw a pentagon versus what the structure actually looks like. One takes me 2 seconds, and the other one takes me, 30 seconds. So the important thing to note is each one of these carbon atoms has 4 bonds. And each one of those bonds are covalent bonds, and a covalent bond means 2 electrons. So there's 2 electrons there, 2 more here, 2 more here, and 2 more here. So that equates to that carbon seeing 8 electrons. And they all have that same situation going on. All of them see 8 electrons because they all have 4 bonds, and each of the bonds is 2 electrons being shared.
Good visual.
Bad drawing, but we could do. How about? Sorry. New tab. Where'd that go? So here's a pretty common molecule is cyclohexane. Hex is 6, so this is a 6 ring. And so you can see there's 6 carbons here, and each one of the carbons has 2 electrons on them. And so the bond between this carbon and that hydrogen is created by these 2 electrons. And the bond between these 2 carbons is 2 electrons. And so then if I look at this, I can see 2, 4, 6, 8 total electrons for that carbon. And then I can move on to the next carbon and do the same thing.
So between 2 of the carbons, they're sharing those 2, but it's considered like its own single one for that specific carbon, if that makes sense. You see how it's like 1, 2, 3, 4?
Yep.
But there's 2 in each of them. So the carbons that share one, that's considered 2, but like in the next carbon, maybe I'm making this more complicated than it is.
Let me try this. Copy image, go over here, Control A, delete, Control V. Oh, I'll put the image. No. All right. Did I hit copy image address by accident? Control V. All right, there we go. Oh, all right, that was a bad color. Sorry. Need something darker. It's hard to see. There we go. So those are the 8 electrons that carbon is seeing. And I put seeing in like quotes. But let's go. This carbon is also seeing 8 electrons, even though 2 of those electrons the other carbon is seeing. As long as they're next to it, it's acting like that those electrons are there. Sometimes they are both possessed by that carbon, and then they get shared back and forth.
Okay, that's what I meant.
Yeah.
Okay, that makes sense then.
Okay. What else we got?
Wish there was more people that did Zoom meetings.
Yeah, I can't really require people because I mean it's online. There is not a meeting time.
Well, there's a Zoom meeting time.
Yeah, but there's no meeting time in the syllabus or in the schedule, so I can't say you have to be here. Plus, a few more people would be great, but if there were 30 people here,
I said more people, but not all people.
right? How common is hydrogen in how common is hydrogen in everything? Hydrogen is by far the most common element in the universe. 99% of all the atoms in the universe are hydrogen. And how often are they in stuff? Pretty often. Um,
What
especially
about
if
carbon though?
especially if there's carbon. If there's carbon around, then there's almost certainly going to be hydrogen in it. If it's organic carbon, there's almost no chance there isn't any hydrogen around. Carbon is not a common atom as far as the universe is concerned.
How is biochar made?
What?
Biochar, biomass.
I don't know what that phrase biochar means.
Um, it's like
You're just talking about charcoal?
yeah, but it's like I guess the wood part of it or something. Like you can use. It's almost like I guess kind of like activated charcoal. Maybe I had heard about it. Know too much about it, but they use it to like absorb like urine in bedding for like chicken coops or like alpaca stalls and stuff. So it like absorbs and they can turn it into compost for gardens.
Carbon itself, like charcoal carbon, it's mildly chemically reactive, so you're not worried about it doing anything bad. And if it's setting on something that is reactive, the reactive thing will react with it. So
Mm-hmm.
absorb is a bad term, because absorb means it's like a sponge. Like I suck this stuff up and then I squeeze the sponge and it comes out, and the sponge is perfectly fine. When carbon does its absorb thing, it's not absorbing, it's actually chemically reacting and turning the substance into something different.
Maybe that's what I mean. Maybe it's not absorbing, but it's changing the.
It's definitely changing the structure, and
So I
it
had seen
and it would
something about that.
absolutely reduce the chemical reactivity of whatever it is in contact with, because
Mm-hmm.
whatever it's in contact with is certainly going to be more reactive than it. And so when the chemical reaction occurs, the products are going to be less reactive.
Mm-hmm.
I'm just thinking about throwing charcoal into a chicken coop, and
Not
then the
not it's not charcoal per se. It's not like a bag of charcoal that you would get at like the supermarket or something, or maybe I'm thinking coal, like coal briquettes.
no, that's charcoal. That's
It is
carbon.
charcoal. Okay, that's not what I'm thinking of. Then it's not the ones that are like produced like that. It's something that's a byproduct that you can make at home.
Well, you can make charcoal at home. You catch some wood on fire and then cover it up with some dirt.
Hmm.
It'll burn slowly, and if you remove the dirt, then it'll have put itself out if you wait long enough, and then there'll just be black stuff there, and that's
I think
charcoal.
that's probably what they were doing was that. Um,
Well, that's how people have made charcoal for years. And the benefit of charcoal is wood's heavy, like really heavy, and takes up a lot of space. And charcoal doesn't. It's not heavy and it doesn't take up a lot of space. So there's less there to actually use. Some of it, basically, obviously, it's been partially burnt. So basically, half of the flammability or the chemical reactivity of the carbon is gone, once I burn it when I take it out of wood, but it's so much more compact and easy to use. Um, I mean, you don't have to split it, right? I mean, what people would do is they'd fell a tree, they'd catch the tree on fire, and they'd cover the tree up with a little bit of dirt and leave. They would come
Hmm.
back later, they'd scrape the dirt off, they'd shovel the charcoal into a carriage, no, not a carriage, a wagon, and then they would go to market and sell it as is. It's a heck of a lot easier to deal with.
Okay. What was the other thing I was going to ask you about? I feel like I never pronounced this word right, but like sequester, but sequestering.
Sequester's correct. Sequestering.
Is there like what's the long? It's like sequestrian or something, or a
Sequester is
sequestration?
no sequester.
That's just sequester. Okay, why did I think it was longer than that? Can you kind of
The,
explain a little bit more about like carbon sequestering?
so a coal plant or a even a
Like,
natural gas plant coming out of the smokestack is going to be a bunch of carbon dioxide. So we don't want carbon dioxide in the atmosphere because it's a greenhouse gas. So instead of the plant just sending that carbon dioxide into the atmosphere, they capture it and then they put it someplace. So that putting it someplace is sequestering. All sequestering means is basically to put something someplace,
transplanting it.
store it someplace else. A person that is in jail has been sequestered. So
Hmm.
when you sequester it, it can be stored inside of something, and if it's stored long enough, it could turn into something else. So if you what people were thinking about is you have all of these holes in the ground that used to be mines. So why don't we just take carbon dioxide and pump it into these mines that are empty and then cover it up? And now the carbon dioxide is not in the atmosphere. That's what carbon sequestering is.
What what about as far as like how plants sequester carbon?
Oh, sure. So again, sequestering means remove it, put it someplace else. So if there's carbon dioxide in the atmosphere, a plant is going to turn the carbon dioxide and water into glucose and oxygen. So a plant will sequester the carbon dioxide that's in the atmosphere and turn it into sugar.
Hmm.
So when Trump says we're going to plant to be a part of the trillion tree plan and plants a trillion trees, those trees are supposed to be growing and they're composed of sugar molecules, glucose molecules. So they're pulling the carbon dioxide out of the atmosphere to make those sugar molecules.
Hmm. Okay, because it's using that uh, carbon, basically eating it, right? Or
Sure.
it's using
That's
it's
fine.
using.
That's fine.
Okay,
Eating's fine. Yeah.
okay. I had seen like a diagram of um, kind of like the process of it because I'm doing a research project in my writing class about um, regenerative agriculture versus conventional agriculture and like um, pasture. Um, oh God, how do I describe it? Rotational grazing versus like conventional cattle and stuff, and how the rotational or the pasture cattle can produce green manure, which sequesters the carbon instead of keeping it in one area. They're basically making like compost from like all the grass that's growing and their poo and everything, and it's adding to that top layer of aggregate of the soil and stuff, and it's adding biodiversity to it, and it's sucking that carbon out of there instead of having like big feedlots where you're getting all um, the cow farts, I guess, all in one area and the poo and everything else, and I'm kind of diving into that right now.
Well, a big part of that is when they pasture graze, they don't produce as much poo and they don't produce as
Yeah.
much. Um, flatulence because they're eating what they're
They're
supposed
grazing
to
on
be
grass
eating.
and not grains.
Exactly. Yeah.
Yeah. That's kind of like where the direction I want to go to with my education.
So the top one's photosynthesis,
Hmm.
and plants are pulling this carbon dioxide out of the air. So it's being sequestered and turned into glucose. So more plants means less CO2 in the atmosphere. So
Hmm.
us knocking down the Amazon, bad idea, because then the carbon dioxide is not being pulled out. And so the top one's photosynthesis, and the bottom one is cellular respiration. So the obvious thing is the plants eat what we get rid of. And what the
Hmm.
plants get rid of, we eat. So we're in a fully symbiotic relationship. So if you destroy the plants, there isn't going to be any of this stuff for us.
Hmm.
So stop killing plants. Because,
Work with it.
yeah.
Add biodiversity.
Yeah, add
Add cover
biodiversity.
crops.
Like
Add to that layer.
how many apples do you know of? Because there's
Varieties?
hundreds of varieties of apples.
Yeah.
And we only really produce about 10 different types.
Yeah.
And
There's definitely no heirlooms in the supermarkets.
nope. There's an experimental farm in New York that's got hundreds of different apple tree pairs sitting next to each
That's
other.
so cool.
And they're just for experimentation. And what they do with them is when, say, get a virus comes out, some kind of microbe comes out and starts attacking Gala apples, they'll go around to this apple farm and look for plants that are completely immune to this sort of microbe, and then they'll take that plant and graft it into the Gala apple, and then that new plant that's a Gala whatever hybrid won't be susceptible to that virus. But if we're not
Mm.
holding on to those plants and we're not allowing them to live someplace, we just kill them off, then we don't have that option.
Yeah. All my garden stuff is heirloom stuff, and I try and save as many seeds as I can.
Yeah, that's all my wife has is just heirloom stuff.
I'm sure you know Baker Creek seeds, right?
Oh yeah, no, we have at least 25 seed catalogs, and yes, Baker is definitely one of them.
Mm-hmm.
I mean,
I think I have like 15 or so.
I'm looking at 10 of them right there, and those are just the ones she's already gone through.
Took me forever to get my Baker Creek catalog. It was like the last one to arrive.
There
Yep.
you go.
Uh-huh.
That's it.
Yep. I love it. It's like the prettiest catalog, other than Territorial. This picture here of like
Oh
the
yeah,
kid
yeah,
dreaming about the big tomato.
yeah. We have that one too.
It kind of reminds me of like James and the Giant Peach.
Sure.
Bethany has a question.
This one?
Yes. Oh, I love it. And they're local, so.
Chapter 6, question 10. Which gases dissolve in water to produce these acids? Okay. Yeah. So, control. So what you have here is, so it says produce these acids. So there's the acid that gets produced, and you know it's in water, so one of your reactants is water. And the other option, water and H2SO4. So really what you do is just some subtraction. What's missing from the top one? Which atoms are missing from the top one? What needs to go right here? That carbon is not on this side of the arrow, so that's got to be over there. There's only one oxygen here. There's two more oxygens that I have to deal with. So what I'm missing on this side is one carbon and two oxygens.
Oh.
So if you take CO2 and put it in water, you get carbonic acid. So if you take a straw and just continually exhale air out of you into water and check the pH of the pH will go down because you're exhaling carbon dioxide, increasing the CO2 in the water, and then you're going to make carbonic acid. So let's do that same thing with the next one. What isn't on the reactant side? What atom is missing?
Is that sulfur?
There's definitely a sulfur missing, right? And then both sides have two hydrogens. The right side is the only one with an S, but we took care of that. The right
SO3?
SO3, because I'm missing three oxygens, right? And so sulfur trioxide,
Mm-hmm.
which is a gas, and carbon dioxide, which is a gas. If you mix sulfur trioxide in water, you will create sulfuric acid. This is one of the pollutants that comes out of a coal plant. So if you live downwind from a coal plant, SO3 will be in the air. And when it rains, sulfuric acid comes down on you. I think it's Donna. Sorry, I'm having a. Denora. Okay, yeah. Denora, Pennsylvania had this fog that was created by burning coal, and the fog ended up killing 20 people because the droplets of in the fog were so acidic when a person breathed them in, they're breathing this in and producing that in their bloodstream, which caused the pH of their blood to drop like a rock. And so as soon as it dropped considerably below 7.4, they just died.
Was this in the book?
I don't know.
The Denora. I feel like I remember reading that or something very similar to that.
Denora is the biggest or the most significant American one. There was another one that happened in California.
Maybe that's what I'm thinking of. Maybe we talked about that last time.
Oh yeah, we talked about the Rose Bowl one, right?
Yeah, that's what
Yeah,
it was.
Pasadena, California, and Sonora, California. But
I remember
Denora,
reading something about 20 people died, so that's why I was like, is that the same one?
the Denora is where the 20 people died. I'm not sure about people dying in Pasadena. I just know a bunch of people had to go to the
It
ER.
wasn't Pasadena. It was like it's supposed to be like a news. It was a news clip from like the early 19s, I think.
Oh, then that was Denora.
Okay.
Yeah, because that's when that happened. There
Okay.
was no EPA, there was no governmental regulation of the market, so it didn't.
There was a picture of it. I'm not sure what chapter it was. I don't have my book in front of me, but I'm pretty sure that's what it was.
Like a newspaper clip.
Yeah.
Oh, okay. Yeah,
It was a black and white photo.
I'm sure it was
Of course
Denora
it
then.
is. I think it's on like the top right side of the right page, from what I remember.
273. Yep. 20-day in smog. Brain clearing air. Has many quit area.
Is it a black and white picture?
Yeah.
Okay. I think that's it, yeah.
Coal. Yeah. Coal. Clean coal. Yeah, that doesn't exist.
Ooh. My husband said nuclear or nothing.
Huh. That's fine. If the federal government would stop screwing around and actually have a place to put it.
Mm-hmm. All right, well, I think I'm good. I don't know if Bethany has any other questions or I'm gonna enjoy the rest of my birthday night.
Oh, well, you should not be here. Go away. Happy birthday.
I got nothing better to do. I'm 31. Nothing for a 31-year-old to do, so.
You can do whatever you want. It's nice out tonight. It's a little cold, but you can be out hiking around.
Oh, yeah. This late at night? Yeah.
Headlamps.
My husband knows me too. He's like, you're gonna be in bed by like 8 or 9. I'm gonna be tired, yawning by like 8:30 because I'm not a late night person.
So when an orchardist sprays trees with sulfur and zinc, what happens? Not good things. I mean, no. Sulfur itself isn't an issue. It's not. It's not going to cause the pH of their bloodstream to drop because it's not sulfur dioxide or not sulfur trioxide, either one of those gases. So it's going to be more difficult for bad things to happen with straight up sulfur. And the same thing with zinc, but they're both particulate and they would cause severe irritation of your lungs. So, I mean, even the Trump administration is up. Well, they haven't done it yet, but they're talking about increasing the regulation for farm workers who deal with all kinds of spraying. That the mask and protective gear that they're required to wear is it's gonna have to be able to block smaller and smaller particles and different chemicals that are in the gaseous phase, which zinc and sulfur wouldn't be, but some of those chemicals will volatilize themselves and turn into a gas. So that means they can't just have a regular paper filter. There's going to have to be some other substance in there that has the ability to absorb those gases. So that's coming.
Protect them a little bit better, protect their lungs and stuff. That's good.
Yeah.
What about the people that do, the guys that fly the planes and do the crop sprayovers and stuff?
It doesn't matter to them. They're not exposed.
Well, I mean, it's in the air. I mean.
No, it's not. Not where they are. They're in front of it.
Yeah, I guess that's true.
And it's not like they're flying open cockpit planes anymore.
Yeah, that would be kind of cool. My husband said he had he would love to do that as a job, just to fly. What are they called? What's the crop dusters? Just do that all day.
Yeah, that's not something that happens a lot anymore.
He's like, I'll do it for free.
Huh.
Is that your dog?
What?
Did you have a dog in the background?
3.
Oh, Jesus Christ. I was like, I saw something run behind you. Okay. All right, I'm out of here.
Okay.
Gonna enjoy the rest of my time while I'm still awake, so.
Alrighty. Have a good night.
Good night, bye.
Bye. Bethany, did you have anything else you want to ask? Is it temporary burning or long lasting? it depends on what it is that they're exposed to. Sulfur and zinc would be short-lived. The sulfur would be, I mean, it totally depends on how fine the sulfur particulate is. But both of those would be short-lived things because they're particles. Yeah, I mean, the best thing the best thing that he can do or anybody can do is invest in a mask that's a true gas mask that actually filters out gases, not just particulate. But if all he's spraying is sulfur and zinc, then constantly changing out particulate filters would be the best thing to do. No problem. All right. See you later, Bethany. Bye.